Okay, everybody. All right, let's begin. So, has everybody got a handout? Right. Okay. Everybody has the last handout, 15, I believe it was. Introduction to Optimality theory at the top. Okay. So yeah, grab those. So just a couple of reminders. First, make sure that you do your evaluations. Very important to our department. Do that both for the lecture and for the section. Two different things. So make sure that you do that. Another quick announcement. I sent a message to my 101 section. So if you didn't get that, let me know. It should have gone through B courses. So it's just a clarification on conspiracy. It doesn't apply for anything else. So if you're in 101, you should have gotten a message. Okay, so today I'm going to do my very best Professor Hyman impression, and we're going to do some more optimality theory. And specifically, we're going to go over some basic constraints. We're going to look at how to apply those constraints within a specific tableau, and within that tableau then to do evaluation of the potential outputs, aka the candidates. And then we'll do something a bit more complex and look at how this applies to tone in Chibemba, which is the mini problem you have at the end of the handout you got on Monday. If you didn't look at it already, that's okay. We'll have a couple minutes to notice some of the observations together, and then put it into a OT tableau. So great, let's begin a little bit of that. And we'll just start by going over a couple of constraints. So I gave you a handout, and this handout should be the core architecture of a tableau, which is OT for table. And we're going to be using that. You should have 6 of them. We might not use all 6 of them. This is generally the sketch. Anytime you do OT, which you can apply to your own life to make decisions, you really can. I've seen it. This is the general architecture you will use. But let's go over a couple of, let's do it here, a couple of specific constraints. So one constraint is just called onset, and all this says is have an onset. So this is core. These are the core ones. You will be responsible for these for the final. I guarantee it. I shouldn't guarantee. I think that's going to come up based on previous knowledge. Of course, so you have to know what onset is. This says have an onset. You need to know what this one is here. The star here is saying don't have a coda. So this is another constraint here which languages use to evaluate candidates. Another type is these types, this depth, which is don't epemphasize. You can think of that mnemonic. And this enforces having no insertion of segments. I put X there to say this means segment. You can have this be depth C, depth B. These are 2 separate ones. This means don't epemphasize a consonant, don't epemphasize a vowel. So this is saying make sure that don't have segments in your output which are not in your input. The opposite of that, so to speak, are these max constraints. And this says don't delete. So this is saying have the maximum number of input segments in your output. And this, of course, can also be max C and max V. Max consonant, max vowel. So, in addition to that, you have ident constraints, saying don't change any features. So if you have voicelessness, don't change it to voiced. So this is particular to features. We have these ident. And then finally, for our purposes here, we'll have something called complex, or I'll shorten it to star CC. This isn't technically correct because it's saying don't have 2 and then maybe 3 would pass. So this is basically saying shorthand for don't have complex consonants. Don't have complex consonant clusters. Don't have consonant clusters. So don't have those together. Now these form, as we've talked about, 2 different types of families of constraints. There's markedness constraints, and there's faithfulness constraints. So of these, which two would be markedness, or which two would be faithfulness, or which ones would be faithfulness? Yeah, come on.
Ident and also.
So ident would be faithfulness.
Max.
So why would onset
I don't know max.
max? Exactly. So we have max, ident, then, and depth. Exactly. So those enforce. We want to have the identical output as input. So those enforce identity between the input and the output. Onset would not be faithfulness. Onset would not be faithfulness. Remember, markedness constraints say I want my output to be a specific shape. I want it to have certain phonological properties. I don't care what you have in the input. My output has to look a specific way. So in these cases, onset would be markedness, and what else would be markedness? Star coda and what else? Yeah, star complex. So we have those specific types. And this is the central tension which OT tries to capture, which was not necessarily captured in a rule-based account, is that we have these different forces acting on the language, and OT is able to model this in a way which rules did not adequately do. Yeah, in the back.
Sorry, can you go over what star complex is again?
Yeah, so that's saying do not have a consonant cluster, in short. So do not have consonants adjacent to one another, directly adjacent. Don't have a cluster. Remember that all of these can be specified, they can be further specified. For instance, you could say, don't have a cluster at the end of a word, but I don't care if you have it at the beginning. Or I don't care if you have it immediately. So we can refine these further. And so these form individual families of constraints themselves. But these are the core ones which we want to take in.
Just to clarify, can there also be either one complex clusters in the onset or the coda?
Yeah. So you can specify where you can have these clusters. Exactly. Yeah.
Just to clarify, the star means it's like no complex, no code.
Yeah, and so it's not exactly ungrammatical, which is where we often use the star, but it means just basically don't. So don't have it. Okay. So with that in mind, let's do a practice tableau. So this would be tableau 1. Now, whenever you're doing OT, it's good to have a pencil and not a pen, as you might have discovered already. So if you have that, that will be beneficial. And make sure if you don't have this handout to come and get it. Right, that's in front. So we'll do tableau 1. And I generally like to do these on, there's different software. You can do it on Microsoft Excel, because then you can freely re-rank your constraints. Then you don't have to worry as much about putting everything in these columns and having to redo everything. So let's look specifically at this input. So this is our input. We have this as our input. This could be morphologically complex. It could be morphologically simplex. Let's not worry about that. We're abstracting away, for the purposes here, of the internal morphological composition of something like this. We'll just treat it in its phonological components. So if we have an order, let's say we have this order. Onset. And we use these convention to indicate that this is ranked higher. It's to the left within the tableau. It's the first part of the evaluation algorithm, so to speak. So we need to do onset, and we'll do star coda, and then we'll do max V, and then we will do depth C. So we'll have those specifically in, and that's the order. And remember, within our optimality theory that we are adapting here, and as a general way to do this, that we're given these constraints, we've come up with these constraints, we also have to come up with the specific candidate set. So there's nothing there's no magic box which is open it up and find all the candidate sets. We have to, as linguists, come up with plausible, possible candidate sets. So one is always going to be the input. So one possibility is always just having complete identical output. Another one that we can have is inserting a consonant. So here we insert a glottal stop. Maybe we also want to insert one at the end. So these are all plausible outputs for this. And say we also want to do ta in these cases. So we have these 4 specific outputs. Here, onset, star coda, max V, depth. So these ones.
FC.
Sorry. Thank you. So we have this with depth C in these types. And now we'll do our evaluation. Yes?
So basically, when you're working with a small set like this, the method of generating candidates would just involve imagining what would happen if one of those constraints was ranked highest,
Mm-hmm.
and then just doing something that matches that.
It's a lot of trial and error going back and forth, especially when you're not given all of the data. For instance, you have a subset of data,
Right,
and you have to just do your best,
right.
and then
Well,
constantly refine it.
But just to get to those candidates, it seems
Yeah.
like you took each constraint in turn and
Yeah, so there's-
conformed to it.
Yeah.
Okay.
Yeah, so there's ways to generate a list of candidates. Basically, the more you do linguistics, the more candidates that you will know would be plausible.
Okay.
Yeah.
Do we know what the surface one is, or the actual output is, or?
We will determine which one based on our
Oh, okay.
candidates, yeah. So in this case, we'll go step by step. So, okay, here. So let's look at these, and we always want to label them A, B, C, and D. And then, does A violate onset?
Yes.
Why?
Doesn't have
Very simple, right? Doesn't have an onset, therefore, we put this violation here. So that's our first step. We put a violation mark there. What about this output? And remember, we're only evaluating here. This is onset, this is a markedness. So we're not even thinking about this part. This is markedness. So we're evaluating the output here. So this output, this candidate, this potential output, does this violate onset?
No.
No. So we'll leave it blank. This one?
Yes.
This one.
No.
So now is where we see we have this here. We have these components, and we see that these two violate this constraint. These two do not violate this constraint. What do we do with these then?
Kill them.
We kill them. Exactly. These incur a fatal violation. So we see this as a fatal violation. We'll look at these a bit more. So the general practice is to gray out these cells. I'm not drawing all the lines. They're given to you already for that, for our purposes here. That's the convention, to gray out that part. Yeah, yeah.
And both of them are fatal because this is the highest constraint?
For our purposes here, I mean, obviously if we were looking at a whole grammar, then we'd have lots of constraints. But for our purposes here, this is the highest rank.
And therefore both of them are just automatically.
Yeah, because we're looking column by column as we go along. Thought I saw another hand. Yeah.
Wait, but what about if, for example, the other two were all starred for every other column except for the first one?
Doesn't matter. So this one, it can have 10,000 violations, but this one can have no violations. It's all about ranking. So there's no cumulative effect going on here. There's nothing cumulative.
Why not?
That's a very good question. Yeah. So the why is for further down the line, next week's lecture, and the how is for today. Yeah.
So if they all violated it for some reason, then you wouldn't gray anything out and you can move on
Exactly.
to the next one?
So remember, so this is a really, really critical point. Say if all of these were starred, and say some crazy world, all of these were starred, it wouldn't be that you would have no pronunciation. It would just be, oh, there's no asymmetries. There's no more violations in one versus the other, so you just move on to the next constraint. So it's all about looking at discrepancies and how many violations there are. So that's a critical point to take home. So let's look at the coda. So for this one, does this violate coda?
No.
So it doesn't, but doesn't matter, right? Because it's already did. So this one, does this violate anything with coda?
No.
This one.
Yes.
So we'll put that there. The general convention as well is that even with something grayed off, you put the star in. This is more important if you want to do constraint re-ranking and look at something diachronic or many different reasons why. But that's generally the case. And then what about this one?
No.
No. So we leave that one blank. So we move on here to max V. So this one, does anything violate it?
No.
Anything violate it? No. Why not?
Has all the same vowels.
Yeah. So there are, remember, these max are faithfulness. These are faithfulness. So we have to evaluate the input compared to the output. So in this one, these have two vowels, ah and ah, and both of these vowels are preserved in the output. Therefore, there's no violation. So I'll answer the question in a second. And then this one, any violation?
No.
What about ta?
Yes.
Yes. We see that the first ah is missing, so we go here. Is there a violation in this column? Is there any type of asymmetry?
No.
So no and yes. Somebody raise their hand and tell me an answer, what they think. Yeah.
Well, out of the two remaining candidates, only one of them has a violation.
Exactly.
It is marked off.
We're evaluating this compared to that. This one is like that. That has a violation. Okay? We have this one. And so by process of elimination, which is the winner?
B.
Ta. And this happens in languages. There are languages which say, even if underlyingly I do not have an onset, I got to put in some dummy consonant. Could be glottal stop, could be T, could be N. It depends on different factors. Typically a glottal stop. And then we still want to do this one. So dep C says what?
Don't.
So don't epithesize a consonant. So which one violates this?
The winner.
So this is also another crucial difference between rules and constraints, is that with rules we have this beautiful thing where we get improvement. It's all about improvement. The input goes to the output and there's an improvement. With OT we always say there's a price we pay. There's a sacrifice. There's always a drawback for doing this, and saying our drawback is that, oh no, we're inserting something which wasn't in the input. But because that is so lowly ranked, it can't influence anything. It's very lowly ranked, so these things will not affect the outcome. So you had a question, so?
It's
There was another? Yeah.
So, are we trying to figure out, like in this instance of this, tableau?
Yeah.
We were trying to figure out what, like we were justifying the surface form that we knew based on a ranking that we knew.
Mm-hmm.
At what point, sorry, I think I'm just still struggling with like what the variable is in this process, like.
So, yeah, I
whether
see what
we
you
know
mean.
the-
So typically what you have, the typical situation is that you have outputs. Like you ask someone to say something and that's what they get. So you have to do a lot of sort of back engineering, so to speak. This is sort of going forward. This is just an exercise to say, if we have these constraints, we have this input, how do you know what's going to be the output? Now, this is practice in doing that. But typically you start out with the only information you have is that this is how it's pronounced. And you have to figure out what's underlying. You have to figure out the constraints. You have to figure out its competitors.
Okay, and so you're kind of doing that iteratively, like.
You're going back and forth.
And so for this then, what we did is we did not know the constraint. We knew the constraints, but we didn't know their ranking.
Yeah.
And we knew.
Well, I gave you the ranking. I gave you the ranking for our purposes here. Yeah, working
Okay,
through.
okay, but if we didn't know the ranking, then we would be doing the process where we did that, but ranking it every single.
And that's the sort of trial and error to figure out what that is. Say if you given this, and then I say, okay, there's another dialect which doesn't have glottal stop insertion at the beginning. How would you derive that? How would you get that? And you could say, oh, I see, these two constraints are re-ranked. And that would be a diachronic application to optimality theory. in the back.
One is not a fatal violation.
It's a fatal violation here because there are only 2 candidates left, this one and that one. And this is saying have the maximum number of vowels in the input and the output as you had in the input. So there are 2, we're only comparing B and D. In this one, both of these vowels are present that were in the input, but here there's one missing. Therefore, this one violates it because there's only 2. This one is a fatal violation.
Because it's higher ranked than the other.
Because this is higher ranked than that.
Okay,
Yeah.
thanks.
Yeah. Ramsey?
If we had a candidate of octave, with its octave, like with an A at the end, would that follow the max vowels, or would it violate it?
No, it would, well, so that's where subscripting comes in OT. Like, is this the same vowel or is it a different vowel? Did you just change the ident or did you delete it and put in an E? And that's sort of, that is where subscripting comes in, and that's where we sort of have to use our imagination, because it's going to be really difficult to find actual evidence for that because they pronounce the same. But that's I'd say on a case-by-case basis. But it would violate something, and if we were not to have that, it would be violating something very high. Yeah?
So like on a test, will it be a realistic situation on final vote?
I don't know. Haven't seen it.
Okay.
Yeah, on record.
I'm still kind of confused about the choice of candidates, just because it would imply that with every underlying representation, we have a list of for every language, it's not just the underlying representation, it's all these categories that comes with the representation and then we filter it out. So it's just how do we have this list of categories unless we're presuming rules beforehand that have been filtered?
I mean, that's a very good point. Actually, someone brought that up to me today. And we just have to generate the candidates, whatever means we have. So whether we are utilizing somewhere in the back of our brains a type of derivational ideas to get these candidates, we just have to come up with a candidate set. As linguists, this is a model saying all candidates are possible. You just have an infinite set, or roughly, like anything plausible. But in terms of evaluating and using this model practically, we have to come up with plausible differences.
So are you saying that technically, there's a candidate that's just literally just
Yeah.
just ignore it because
You could have a candidate which is a pink butterfly, and there would be some faithfulness violation for that. Okay, so it's something which it's definitely something in terms of intellectually and even philosophically hard to wrap your head around, but in terms of practically, we just have to come up with logically plausible candidates. Yeah.
How large is the
sorry.
pool of universal constraints and where?
Depends on your theory.
That pool?
Well, you can read as much OT as till your eyes bleed, and then you'll see the different possibilities. But I mean, it depends on if you think of the constraints as universal, which is the null hypothesis maybe, or if you think that they're emergent language by language, and that learners posit them to account for facts as they go. It's depends on how you want to do linguistics.
That second one is interesting because that wasn't brought up before. So
Yeah, and you're not going to be responsible for that.
no, but I'm interested in it.
Yeah. So we are going to assume that these constraints are universal. And certainly, even if they are emergent, all of these emerge in 100% of languages. So at some degree. Very close.
So, I'm trying to figure out where multiple violations
Yeah.
per thing comes into play. If we had, for example, an E has the glottal stop in onset and coda, would that only be knocked out because it would violate Dep C twice?
Well, I don't want to look too much and manipulate this too much. There is an example of multiple violations of the harmony that Professor Hyman brought up on Wednesday, saying that something violated a candidate twice. So if I have 3 candidates, 2 of them violate the constraint once, and the third one violates it twice, that one which violates it twice is eliminated. That incurs a fatal violation. So that will happen any time you have a violation of something twice. So you have OCP, and there's 2 OCP violations, then you have it twice. So it's really it's as simple as that. It's just whenever you see 2 violations of something, you have 2 stars. And in that sense, there is some cumulativity. Yeah. Wow.
So there's an example of that in the 24 image that.
That's 24 if anyone can't do it.
I was just wondering why in column A, the fatal violation is high and not the mid.
You mean row A? What's column A?
Oh, sorry, row A.
Row A. So why is the fatal violation?
The high, not the mid.
So this happens because if we look at C and D, so yeah, this will not set us, this is good. So C and D are both already eliminated. So we see here that D violates column 1, C violates column 2 twice, so therefore we see this asymmetry. A and B both violated only once, so we move on. They're both equal. So if they're equal, they both pass. And then we see, those are the only 2 candidates we're considering now, A and B. We see that only A violates the 3rd column. Because that's the only violation there, that one is then eliminated. That is a fatal violation. So it's only a fatal violation if and only if there is some type of asymmetry. If you see that I'm violating it but my competitors are not, you're done. But if you're both equally bad, you both go on to the next round.
Sounds like voting.
Yeah, something. I said this was all like eliminate, but I don't know if anybody got that. I think that's a show of olden days. Okay. All right, so we have this. So we have 25 minutes. So let me just sketch out something quickly, and then we'll do the last 20 minutes looking at the Chipemba. So that'll be a good amount of time. So I'll just do this quickly. I will not do a full tableau for this. You can worry about that on your own time when you're studying. And remember, we have office hours next week and there's a review session. So there's more time to go over this. Say we have an input which is spat, a spot actually. I will do my best IPA spot, like this. And we have the winner. We have A, like this. Our winner is CPOT. That's our winner. We have this. What would be a potential competitor with this? So raise your hand, tell me a potential competitor, yeah. So what would be another candidate?
Oh, cat?
Yeah.
Hot?
Hot? Or sat?
Oh, sorry.
And let's only think about this in terms of, we know that this is our output. We know this is what we recorded. We've done our work. We've worked with our speaker. They're consistent in this pronunciation. And then we have good evidence that this might be the input. Let's not worry too much about richness of the base right now. For our purposes, this is our input. So what would be another competitor? Yeah?
Inserting a different vowel instead of vowel?
Yeah, so we could have sepat or something. So schwa, sepat. And what would be another one? Any Spanish speakers in the room might want to think of another.
Espat?
Espat. Well, let's do ispat. Or, I don't know if you can read this, I'll put G over here, since we're not actually doing this.
Wow.
Maybe there's some other thing which you have double epemphasis for whatever reason, like that. We have these different ones. So we know that this is the winner. So when we have something is the winner violates something. Every winner violates something. This is a universal in OT. There's always some drawback. So what does this violate? Which of these constraints does that violate? So somebody raise your hand. Ramsey, tell me. Depth V, exactly. So would that be highly ranked? No, very low ranked. Not maybe the lowest. It depends on the vast choreography you need to do when you're not just dealing with individual words and you put all of your constraints together. But we know it's lowly ranked in terms of our problem set here. So let's think about this. What would eliminate spot? Yeah.
Star complex?
Star complex, exactly. So we have something which is star complex. So what if we want to think, let's actually make this a little bit more complicated. And we have this one, there's something like CC, and we have this, let's say here, onset. So I just made that up. I just put that together just to conventionalize it quickly, saying that we have this at an onset position. So we have that. So we have this. So this spot, would this still violate that?
Yes.
Yes, because I don't think that we could syllabify S. That's not really a thing. So it's spot. Both of these would be onset. So these ones, would that violate it? No, there's only one constant. So we've eliminated that to satisfy this complex, which is saying don't have those in onset position. We've eliminated it. What's our sacrifice? Okay?
It would violate max.
Yeah.
B.
Max
C.
Max C. Max C. So it would violate a constraint saying have the maximum number of output segments from your input. So it violates max C. So we know max C is up here somewhere for these ones. And then for this one, how do we determine between these, whether we have for epenthesis, whether you have C or S or sepat or supat or sapat, all of these different possibilities. Anyone who studied languages knows that epenthesis is on a language by language basis, and sometimes even a construction by construction basis. Maybe this part of stratum 1 does something different from stratum 2. So we have to build in some constraints which choose between those. We won't dive into those here. None of these are going to really decide that, but that's something we've seen also from the harmony case that we talked about from Jill Beckman's work. Sometimes you just have to say star mid is higher than star high. So you might just have to say star ah is higher than star e. So have less ahs in a word than e's in a word. Yeah?
I noticed that you used the schwa and the glottal stop, but are they almost like placeholders in OT where you don't want to just say like...
They're the most common epenthetic. Well,
Okay.
to my knowledge, maybe I could be wrong.
Okay.
But I think schwa and glottal stop are extremely common to be epenthetic segments.
Okay, so it is more likely, if those aren't just being used kind of like...
Those are the unmarked values,
Oh, got it.
cross-linguistically.
Okay.
And then this one, what might eliminate E spot? Does E spot, does that violate this onset?
No.
Something like that? No, it doesn't violate that because S is what? In what position? Coda. It's in a coda position here. So we have that. So why might we not like E spot? Yeah. Dep V, which is also violated here, right? So what might be a problem? Yeah.
Onset?
Yeah, maybe we have this language also needs onsets at the same time. Yeah.
So with OT in general, like, I mean, I think it does this, but we're losing any generalizations we have about feeding and bleeding, right? Because
Ooh, that's a big one.
yeah.
So I was talking a little bit about issues of feeding and bleeding. So this is a non-derivational model. So there really isn't ideas of feeding and bleeding built into it. That's a whole separate enterprise of research going on right now. I won't say anything more. Just think of this as not incorporating feeding and bleeding for the moment. But if you go on and have successful careers in linguistics, you'll dive into that deeply.
Sorry, I keep going.
Yeah. So, and then what would eliminate E spot? Why can't we just say, oh, let's repair the epenthetic vowel and put a glottal stop before it? Sorry? I heard someone say it. Dep C. Yeah, maybe we have that. So you have Dep C hyphenate. So all of these would be eliminated by something when we go through, step by step. We want to make sure that we eliminate. So all of your competitors need to be eliminated by highly linked constraints. That is the general principle. Let's look, where is my thing here? Let's take this and let's think about the Chibemba cases there. So this is on page 5 of that handout before. If you don't have it, make sure to look on with a neighbor. And there is not a lot of data here. It says 12 forms, but there's some interesting patterns we need to account for. So the first thing to notice is that you see a number of the forms have underlines. Those underlines mean that's where underlying high tone is. Underlying high tone, so in the input, would be where the underlying segments are. So take a minute, look at this data, and try to see what's going on. What are the key observations we need to make for this data? Good enough. Okay, so let's come together again and tell me, what is one observation? So we're not going to theorize here, just if you need to describe to a language learner what to do to speak this language correctly, you have underlying highs at certain places. What's one observation we need to make? Yeah.
It seems like we have a high tone spreading.
Okay, what would be the key data? What's the key data for it?
Well, we have things like tula kaka, tula kaka, litaya.
Yep, so that's 29A, first one.
And then we have k, kak has an underlying low tone. So then we have tula ba, kaka.
Mm-hmm.
We tie them up where now, because kak follows ba, it now carries high tone.
Yeah, so we see that 29A for the third set, we see that underlyingly ba is high tone, but the kak one next to it, that one gets high tone as well. So we have a spreading. Is this spreading bounded, unbounded? What kind of spreading? What's the generalization for this spreading? Yeah?
It seems like it's only spreading to one syllable.
Yeah, it's spreading one to the right. It's spreading only one to the right. And we have evidence for that because we don't see it on the final vowel ah in that case. In 29C, we have ba in the initial position, and we see this also spreading. In 29B, the first one, we see that sum is the high tone, and that is spreading one to the right. So this is a robust generalization. Yeah.
Yeah, what about the third one in 29C? Why doesn't that law take
Mm-hmm. So what's the observation to make there?
It doesn't always apply.
It doesn't always apply. So what would be a hypothesis of when it doesn't apply? Yeah.
I
Sorry.
think there's a stronger rule or a rule that applies after if we're talking about rules.
Yeah.
That before an underlying high tone is always a low tone.
So before, what about 29D, the last example?
Or like before like the first underlying high tone in a series of underlying high tones.
Okay.
Is it like a constraint? You can't have 4 high tones in a row?
So what would be a constraint we saw against high tones? Yeah.
Oh, I was just gonna say, it seems to me more like if there are 2 underlying high tones and then there's a morpheme in between them, that one's gonna be low. If
That
it's
one's
between
going to be
2
low.
underlying.
Yeah, so that's the generalization. So when we see that there is, I'll put here, we have, I'll just use syllables. We have high tone, high tone. If we have another syllable in between, we see that that is a low tone. So what is not taking place with this syllable? Yeah.
The high tone spread doesn't take place.
It does not take place. So we see that if it's like this, we get something like, let's see here, yep. But if it's like this does not take place, this high tone spread. what might be a plausible reason why you do not get high tone spread next to another high tone? What would be a plausible reason? Yeah, Laura. Yeah, it could be a morpheme boundary, but let's assume that this is a phonologically general constraint. Yeah, Michael?
OCP?
OCP. You don't get high tones next to one another. They gotta be separated by a low. So we do not get high tones adjacent to one another. So let's start to model this in a specific type. Let me switch to my other one. Into an OT tableau. Okay. So we see here that what would enforce spreading? So what type of constraint would we need to enforce spreading? So we see it as high tone spread, and that's a result of a constraint. What constraint would give us high tone spread? Make it up. Spread. This is how OT works. You think of the generalization, and then you say, this is now a constraint. Okay? Yeah, Amanda.
How do you decide whether you want to make the constraint a positive declaration instead of a negative one?
I think I want to say aesthetics, but maybe someone would argue against me who knows more about OT. Generally, there are certain things which are just conventionalized. Like, for instance, we have in this one saying have an onset. This one's saying don't have a coda.
Yeah.
This one could just say don't have a have a consonant at the end. This says don't have a vowel to, at the beginning of the syllable. There's all different ways to formulate it. So some of that is just conventionalized, but they should be basically translatable one to the other. The most important.
Logically equivalent, or would
Yeah, I think so. Yeah, they would have the exact. There would be no difference in your analysis.
Okay.
Yeah. Yeah.
Is that also the same reason why it's not star F instead of def? So
Yeah. I mean, some of these things, like you could formulate all of these by saying that they're not stars. There's a different way to formulate it. So really, just think of these. The constraints themselves are really no different from what we emphasize when you wrote rules. Just give your rule a label. Just say that it's I raising, or it's E epiphysis, whatever you want to call it. That's less important than formulating the rule itself. Just like here, we're formulating the constraint itself. What we call them is less important. That's more a conventionalization from the OT literature, the culture. Okay, so we have this. So we have, what we're doing? Yeah, we have spread. So this will be one feature. So this is saying spread high. And let's say that this is conventionalized as saying spread one to the right. Yeah,
That was my question.
okay, yeah.
The direction.
So, and those sorts of things, those will come out in your definitions. So just like you had rules which said there was a specific environment, the environment is not built in, the application itself is not built into the name of the constraint. You just have to define the constraint. And it's anytime you read an OT paper, that you will see that there's going to be a list of constraints which are defined. Yeah?
I'm envisioning a situation where we could say that the reason that we don't see a high tone is either because of the OCP or because it only spread one to the right as opposed to spreading to the right.
Yeah, there could be there's always competing possibilities. And then you need a vast amount of data to determine that.
Okay,
Yeah.
so you're basically just deciding one.
Yeah, we'll just decide this is
Okay.
applying now.
Got it.
So if this is what we always know that something is sacrificed, so what would be a sacrifice? So when we have spreading, what is violated? Faithfulness. Faithfulness to what?
Oh,
To underlying tone of low tones. So we have this is ranked above faith, low. So that we can put this here in our types, so we can have, say, what is this? This would be spread high is above faith, low. So if we have a candidate then, and we put that in, And we have something like 29C, the last one. Bala bakaka. So they tie them up. I'm not a native Cuban. So we have that, and this, we see that spread high does not take place. So what would this violate if we have that? If we had spread high in this case, what would that violate? The OCP, right? OCP high is saying do not have two highs adjacent to one another. Now remember, we're talking about that they're linked to the same underlying high, right? We can have them spread. So we want to put here OCP high. And for this one, I just want to then emphasize the last thing that we have here is 29D, the last one, which is ba, la, ba, sum, a. So we have three underlying highs, and then we can have a number of potential candidates. So we could have ba, la, ba, sum, a. So we always have this one is identical. Another possibility is you have spreading here. So we know that this one, bala basuma, we know that this one will violate nothing here, so that it violates spread high, because you need the spread. Bala basuma. This one with bala basuma, with this one would violate OCP high, because you would have ba and la next to one another, and next to ba, and all of those would be high tone. So let's look here. The output is this one. Ba, la, ba, sum, a, bala, basuma. So we have these ones high, and we see here that these two underlying highs are adjacent to one another. So we know that this also violates the OCP in these cases. So why would that one not be eliminated? Why in 29D, when we see two underlying high tones adjacent to one another, why is that okay? Why is that the surface form that we see? What's the other super highly ranked constraint that we need?
Identity of the, no, sorry.
Faith? Do I hear faith?
Faith high.
Faith high. Exactly. Faith high in this case. So we might think that this one should win. So if we have something which is ba, la, ba, sum, a. So this one would be a case where it does not violate the OCP, because the ba and the sum are different tones. This is high, this is low. But we see that there are three high tones in the input, so this one does what? Violates faith high. So we see here that this one here, this sum, is changed from a high to a low. So the key generalization here is anytime you have an input high in this language, it never changes to low. Lows can change to highs, highs never change to low. The OCP, there is tone spread, but only if it doesn't violate the OCP. However, the OCP cannot affect the underlying tones. And that's because the OCP is ranked lower than faith high. If you were to be a sister language which said, no, I really care about the OCP, then you would lose that entirely. Then you would get rid of those underlying tones. So then this one is violated in this case. Yeah, Ben.
I think I answered my question, but is it necessary for the OCP constraint to specify high? Or is it okay, because OCP is kind of broad in general, or are we only applying to high tones?
I think, yes. I don't think the OCP, I mean the OCP could be for any phonological phenomenon. So I think you do need to specify it to the specific phenomenon you're discussing.
Yeah.
Yeah.
Right.
So why is it the output A?
The output is A because this, it's not A, in these cases, violates spread. In these cases,
Oh,
yeah.
Wait.
So then,
But the actual
what?
output C violates.
But C is violating.
oh
That
no,
would be fatal.
oh no.
Oh,
Yeah. In these cases here, we would have the faith violation here to eliminate these ones. And then we would have our spread is actually highly ranked. We'd have that. Sorry, I put it, this is why we have to do pencil. Yeah, sorry about that. And then we would get it to all come out. Yeah, sorry, I don't have time. I have to stop now to recap that. But it does work, yeah.
But if you rank higher, or if we rank spread higher than what we get law as high?
I'll do it after I have to stop. Okay. Thanks guys, sorry.